So this is the first problem of the continuity. Check the continuity of a function given by f of x is equal to 2x plus 3 at x is equal to 1. First we need to analyze the things. We need to check the continuity of the given function. The given function is f of x is equal to 2x plus 3 at x is equal to 1. X is equal to 1 means we need to check the continuity of the function at particular point C. C means x is equal to 1. So first we need to verify that f of c is exist or not. F of c means f of 1 is exist or not. So given f of x is equal to 2x plus 3 at x is equal to 1, we need to check that f of 1 is exist or not. Therefore f of 1 is equal to 2. Instead of x we are going to substitute the 1. So 2 into 1 plus 3, 2 into 1 means 2 plus 3 is equal to 5. Then f of 1 is equal to 5. So first step is going to be easy. So first step is clear that f of 1 is equal to 5 and f of c is exist. Second step we need to verify that LHL is exist or not. So LHL means limit x tends to c minus, c means 1 minus f of x is equal to limit x tends to 1 minus f of 2x plus 3. So next we need to apply the small quantity. That small quantity is going to be h. By using the LHL we can apply the small quantity. It's nothing but limit, instead of x it's going to be replaced by h. H tends to 0, h tends to 0, f of 1 minus h. What is the value of 1 minus? Why we need to apply the 1 minus h? Because we are applying the LHL. We are applying the LHL means 1 minus h. So in simple way we have found that a minus h, instead of a we have found that a is equal to 1, it's applying that 1 minus h. So clearly limit h tends to 0, f of x is equal to 2x plus 3. Instead of x we need to replace the 1 minus h instead of x. So applying 2 into 1 minus h plus 3. So limit h tends to 0, 2 into 1 minus 2 into h plus 3. So limit h tends to 0, 2 minus 2h plus 3 is equal to limit h tends to 0, 5 minus 2h. Now applying the limiting value at particular h tends to 0, then the 2h is going to be 0. So clearly the LHL is going to be 5. So we have found that f of 1 is equal to LHL. F of 1 is equal to LHL because f of 1 is equal to 5 and LHL is going to be 5, then 5 and 5 going to be equal. So clearly f of 1 is equal to LHL and LHL is exist and it is going to be equal to f of 1. Like that we need to verify that RHL also. So RHL implies limit x tends to 1 plus, because the given point is going to be 1. When we not apply, we need to find the LHL means we are going to apply the small quantity on RHS. So applying that 1 plus, limit x tends to 1 plus f of x is equal to limit x tends to 1 plus f of x is equal to 2x plus 3. So we are applying the small quantity h on RHL, then we are applying limit h tends to 0, f of 1 plus h. In LHL we have found that limit h tends to 0, f of 1 minus h. So we are applying that limit h tends to 0, f of 1 plus h. So next step is going to be limit h tends to 0, f of 1 plus h means 2 into 1 plus h plus 3. So clearly limit h tends to 0, 2 into 1 plus 2 into h plus 3 is going to be again limit h tends to 0, 5 plus 2h. Now we are applying the value of h. So clearly is going to be equal to 5. Similarly f of 1 is equal to 5. So RHL is going to be 5, then f of 1 is equal to LHL is equal to RHL. So f of 1 is equal to LHL is equal to RHL is equal to 5. So therefore the given function f of x is equal to x plus 3 is continuous at the point 1. The given function f of x is equal to x plus 3 is continuous at the point 1. Therefore, the given function is continuous at x is equal to 1. So next question is, prove that the function f of x is equal to 5x minus 3 is continuous at x is equal to 0, x is equal to minus 3 and x is equal to 5. So first one, at x is equal to 0 we need to check that the given function is continuous or not. Likewise, the given function is f of x is equal to 5x minus 3. At x is equal to 0, f of 0 is equal to 5 into 0 minus 3 is equal to minus 3, because here we are applying the value of x by 0, we are interchanging the x by 0, we need to check the continuous of the function. So f of 0 is equal to minus 3. Similarly, to find out the LHL, so LHL implies limit f of x extends to 0 minus, so limit extends 0 minus 5x minus 3, because f of x means 5x minus 3. So suppose we are applying the LHL, we need to apply the small quantity. So limit h tends to 0, f5 into 0 minus h, because we are applying the LHL means a minus h. Here a is equal to 0, so clearly 5 into 0 minus h minus 3. So limit h tends to 0, 0, because 5 into 0 is going to be 0, 5 into minus h is going to be minus 5h and minus 3. So limit h tends to 0, minus 5h minus 3. So then we are applying the h value, h is going to be 5 into 0, then it is going to be minus 3. So similarly RHL, so limit x tends to 0 plus f of x is equal to limit x tends to 0 plus f of x is going to be 5x minus 3. So similarly limit h tends to 0, 5 into 0 plus h, because we are applying the RHL is going to be a plus h, here a is equal to 0, similarly 5 into 0 plus h minus 3. So 5 into 0 is going to be 0, 5 into h is going to be 5h, so minus 3. So limit h tends to 0 plus 5h minus 3, so h is going to be 0, then 5 into 0 is going to be 0, is clearly minus 3. So RHL is going to be minus 3. We have found that, so we have found that the given function is continuous at x is equal to 0. So f of 0 is equal to LHL is equal to RHL. Then we can say that the given function is continuous at the particular point x is equal to 0. Here in second one, that the given function is f of x is equal to 5x minus 3. At x is equal to minus 3, we need to check the continuity of the given function. So first we need to apply that. F of minus 3 is equal to 5 into minus 3 minus 3. So 5 into minus 3 is going to be minus 15, minus 3 is equal to minus 18. So f of minus 3 is equal to minus 18. So first we need to check the LHL. LHL means limit x tends to here minus 3 minus, because the given value, the given particular point C is going to be minus 3. So LHL means minus a, C minus, so like that minus 3 minus f of x, so is equal to limit x tends to minus 3 minus 5x minus 3. In LHL we are applying the small quantity, limit h tends to 0, we are applying the h tends to 0, 5 into what is the value of a, minus 3 minus h minus 3. So limit h tends to 0, 5 into minus 3 minus 15, 5 into minus h minus 5h minus 3. It can be said that limit h tends to 0 minus 18 minus 5h. Now we are applying the small quantity h is equal to 0, then 5 into 0 is going to be 0. So answer is going to be minus 18. RHL is equal to, LHL is equal to minus 18. Similarly, we need to find that RHL. RHL is equal to limit x tends to minus 3 plus f of x is equal to limit x tends to minus 3 plus f of x means 5x minus 3. Similarly, limit h tends to 0 because we are applying the small quantity h. So, limit h tends to 0, f of x is going to be 5 into minus 3 plus h because we are applying the RHL. So, a plus h, here a is equal to minus 3. Similarly, 5 into minus 3 plus h minus 3. So, like that, limit h tends to 0, minus 15 plus 5h, here minus 5h, here plus 5h. So, minus 3. So, limit h tends to 0, minus 15 minus 3 minus 18 plus 5h. Now, we are applying the value of h is equal to 0, then 5 into 0 is going to be 0, 0 plus 0 minus 18 is going to be minus 18. So, RHL is equal to minus 18. So, we have found that f of minus 3 is equal to LHL is equal to RHL. So, is equal to minus 18. Therefore, the given function f of x is continuous at x is equal to minus 3. So, next question is, the function is f of x is equal to 5x minus 3. We need to check the continuity of the given function at the particular point x is equal to 5. Then the given function is f of x is equal to 5x minus 3. Then f of 5 is equal to 5 into 5 minus 3 is equal to 5 is the 25 minus 3 is equal to 22. 25 minus 3 is going to be 22. Then f of 5 is equal to 22. So, we need to check the LHL now. LHL is equal to, LHL implies that limit x tends to 5 minus, because the given point is a is equal to 5, then x tends to 5 minus f of x. So, limit x tends to 5 minus the given function f of x is equal to 5x minus 3. Now, we are applying the small quantity limit h tends to 0, 5. What is the value of a? A is equal to 5, then 5 minus h minus 3. So, limit h tends to 0, 5 is the 25 minus 5 into 5, 5 into h, 5h minus 3. So, limit h tends to 0, 22 minus 5h. So, suppose we are applying the h is equal to 0, then 5 into 0 is going to be 0. So, we have found that LHL is going to be 22. Similarly, RHL is equal implies limit x tends to 5 plus f of x is equal to limit x tends to 5 plus f of x is nothing but 5x minus 3. So, limit, suppose we are applying a small quantity h tends to 0, 5 into 5 plus h, because we are applying a RHL, we are applying the small quantity on RHL, then it is going to be a plus h. A plus means a is equal to 5, here 5 plus h minus 3. So, limit h tends to 0, 5 is the 25 plus 5h minus 3 is equal to limit h tends to 0, 25 minus 3, it is going to be 22 plus 5h. Suppose we are applying the h value, h as 0. So, 5 into 0 is going to be 0, 0 plus 22 is nothing but 22. So, RHL is going to be 22. We have found that f of 5 is equal to LHL is equal to RHL. Therefore, the given function f of x is equal to 5x minus 3 is continuous at x is equal to 5. continuous at x is equal to 5. The given function f of x is equal to 5x minus 3 is continuous at x is equal to 0, is continuous at x is equal to minus 3, is also continuous at x is equal to 5. Likewise, we can find number of problems by using the limiting values. By applying the limiting quantity, we can find that the given function is continuous or not. Suppose if we have found that f of a is existing, LHL is existing. Suppose the RHL is does not existing, then we can't say that the given function is continuous. Suppose the three functions are existing and f of a is equal to LHL and RHL is not satisfying, then only we can say that the given function is not continuous. So first we need to verify that f of a is exist or not, LHL is exist or not, RHL exist or not. Then finally we need to check that f of a is equal to LHL is equal to RHL. Then only we can say that the given function is continuous at the given particular points.